Okay, so if you're watching this at home, I asked everybody to use the third page of Force Notes 2 and to make free body diagrams for the system where you have a diagram for M1 that's separate for M2. So if you're watching this from home, hit pause on the video right now and then give it a try. But I think we're all back in the classroom now, and I want to look at this together with everybody, okay? So my question is, did you get this? You didn't have to do the system, but if you did the whole system, you can see I've got it looking kind of like a train. The mass 1 and mass 2 are together. And this is the first time you're seeing me not use W for weight on these. So I told you you could do that, but this is what it would look like. The weight vector here is the mass of the system times G. If I'm just looking at mass 1, I have M1G or W1, either one is good. And then N1, the normal force lifting block 1. It is important to have those subscripts because you have different ones. And then I have the force applied. That's the big glove or space mitten up there that's pushing. And there's some friction in the opposite direction. And I went ahead and put a subscript on that also, right? Because it is dependent on the normal force, so that might be different for the two. So this one looks the same way as these others, right? We have forward, but instead of the applied force from the mitten, it's the force of block 1 pushing on block 2, so denoted like that. We have its own friction, its own weight, its own normal force. Do yours look like that? Does everybody agree? Anybody have anything different? Trying to get you all up here at once so I can see you all at once. As I say, that's all wrong. Well, I take that back. It's not all wrong, but that is wrong. Something is missing, okay? Something's missing. One of those is not correct. Anybody know what it is? Anybody have any idea? Here's my hint for you. Which one of Newton's laws am I thinking about when I clap my hands as a hint? What do you think? What do you think? Yeah, I think I'm agreeing. Dominica's doing this. It's third law. If object 1 pushes on object 2, if object 1 pushes on object 2, right there, it's object 1 pushing on object 2. What other force is there? Isaac Newton was telling us forces don't come singly, they come in pairs. If 1 is pushing on 2, then 2 is pushing on 1. Right here, we are missing a force. Right here, like that. I need the force of block 2 pushing on block 1. Wow. So when you write your net force statements for these two scenarios, they're going to be different. This one is going to have 3 terms in it. It has the negative direction of the force of 2 pushing on 1. It has friction in the negative direction, and it has the applied force. Wow. Versus the other situation where you have just friction in the negative direction and the force of the big block pushing on the second block. That can really make a difference in your problem solving. Okay, so I want you to see that. Interesting. Now, let me show you one more thing. When we look at the whole system, we could actually put those 2 contact forces in. Because if I sum all the forces in the x direction, there is a force right there. This is the normal contact force of M1 pushing on M2. So I could just call that a normal force also. So I could go, let's see, I have the force, I have friction in the opposite direction. I have the force applied, right? And then I have this normal contact force. So normal contact 1, I'll say, in the positive direction. But what else do I have? I have this normal contact force of M2 pushing back. So if it's pushing back, then that would be a negative. So that would be plus a negative, I'm almost out of room on my paper, normal contact 2. You see what happens? See why it's okay to leave those out? They sum to 0. So the net force doesn't have to consider those because what I have here are just forces external to the system that are causing the acceleration of the system. All right, so we have left 2 minutes in class. See if you can make that numerical right now. Right down there is a little challenge to make it numerical. It says, hey, this really is on the International Space Station now. So if that's true, friction and the table are gone. So the masses are just kind of floating in the air, but they're together and they're touching. Okay, and that big astronaut glove is pushing on them. Find the acceleration and find the contact forces given these things. When you have a situation like this where M2, and M1 are kind of confusing, feel free to change your subscripts as long as you communicate at the end. Like if M1 is the 3 kilogram mass, you can do this if you want to. Rename it, call it M3. If that helps you, keep things straight, it's worth doing, okay? All right, so before Friday's class, you should have gotten Force Notes 3 from the Force Notes 3 video. It's 15 minutes long. That's a blended learning assignment for you to do between now and then. But it is now 2:14, so you are free to do whatever you need to do to get ready for period 4. Bye. Thank you so much for your work today. Thank you, those of you being honest on the quizzes. Appreciate you so much. And I'm still here. No rush. I just thought I'd let you pack up because I know some of you here are actually having to walk to another class soon.